Hello! In this presentation, I will show you how to perform a comparison between 3 or more measurements of the same variable on the same sample using the repeated measures ANOVA. I advise you to work along with me on the SPSS database called Adolescents Behavior 4, which is attached to this course. Please remember that in this database, the only difference from the previous versions that we used in our presentations, which were Adolescents Behavior 3 or less, is that the self-esteem and the academic self-efficacy of the participants were measured in 3 different moments, that is, in 3 consecutive semesters. I introduced this additional element to our database in order to have the proper variables to illustrate the comparative tests with repeated measures. So you can see these variables here. As in the previous presentations, I will describe all the procedures that I will use, but I will not go deep into the statistical formulas. If you want to understand or to consolidate your basic statistical knowledge, I advise you to enroll in another course of mine from this platform called Introduction to Statistics for Non-Mathematicians. So, let's begin. The objective of our analysis will be to find out if there are significant differences of self-esteem on the same sample of adolescents between the 3 consecutive semesters in which self-esteem was measured. Generally, when we have more than 2 repeated measures, we cannot use the repeated measures t-test several times because this could lead to the escalation of the probability of false positive results. That is why, when comparing 3 or more repeated measures, we must use the ANOVA procedure. First, I will select Analyze, General Linear Model, Repeated Measures. In this new window, on the upper side, we have to name the within-subject factor. In our case, having repeated measures of self-esteem, let's call it repeated.self.esteem. Repeated.self.esteem. I use the dots because, as you remember from our initial presentations, SPSS does not allow you to have free spaces in the name of the variables. In the area below, we have to define the number of levels, which is actually the number of repeated measures. In our case, we have 3 consecutive measurements, so I will introduce the value 3, and I will click Add. In the following area, we have to give a name for our concept, which in our case is self-esteem. So I will write self.esteem. And I will click Add and Define. Now, as you can see, in the left side of this new window, we have all the variables from our database, and in the right upper side, we have an area called Within Subjects Variables, in which we have to introduce the first, the second, and the third measurement of self-esteem. So, I will introduce total self-esteem 1, total self-esteem 2, and total self-esteem 3. The next area is called Between Subjects Factors and is dedicated to other factors than self-esteem, which means variables that divide the participants in subgroups and that we want to include in our model. As far as in this presentation we analyze only the repeated measurement of self-esteem, we will leave this area without any input. In the lower part of the window, we have an area called covariates, in which, for more complex models, the covariates of the dependent variables should be introduced. Because in our simple model it is not the case, we will leave this area without any input. Now, you can see also that in the right side of the window we have a set of vertical buttons, and most of them includes different indicators or commands for more complex models, so I will not describe them right now. Instead, the only button of interest here is Options. The only option of interest in this project is Descriptive Statistics, so I will click on it. I will click also Continue and OK. In the first table from the results section, we have the order of our measurements. In the second table, we have the mean and the standard deviation of the self-esteem measured in each of the 3 moments. As you can see, it seems that the mean value of self-esteem increased from one semester to another, but the dispersion of the data also increased. So let's see if under these circumstances the differences between the repeated measures are statistically significant. But until then, let's inspect the fourth table called Moschli's test of sphericity. This table includes a test of sphericity, which is an important assumption of the repeated measures ANOVA. Sphericity is the condition where the variances of the differences between all pairs of measurements or levels are equal. So the fourth table presents the result of the Moschli's test of sphericity. As you can see, based upon the level of significance for this test, which is smaller than 0.05, for our data, the assumption of sphericity is violated. So the variances of the differences between all combinations of levels are not equal. This means that in the next table, called tests of within subjects effects, which contains actually the results of ANOVA with repeated measures, instead of inspecting the first f variable, which corresponds to sphericity assumed, which is not the case here, we will have to inspect and interpret the other 3 indicators, which are corrected values of f, correction performed, for sphericity not assumed. As you can see, all the corrected values with Greenhouse-Geiser, Huindfeld and lower bound corrections indicate that there are statistically significant differences between our 3 measurements, because the significance levels for these values are smaller than 0.05. So we can conclude that the self-esteem really increased from one semester to another. So these were the most important steps in performing the repeated measures ANOVA with SPSS. See you in the next presentation, and don't forget to leave a review.